All right, so for this first one here, and again, I like that this is something that I always encourage students to do, is kind of to draw these lines, because every line that you draw is representing a multiplication that needs to take place. Okay? So as you get more and more advanced, there's going to be more and more stuff inside your parentheses here. So like when you get to Algebra 1, there might be 3 or 4 things inside these parentheses. Each line represents a multiplication that needs to happen in all of those. You get to Algebra 2, you might be talking about 6 or sometimes 9 multiplications that need to take place using the distributive property. Every line you draw represents a multiplication. So here, we are taking 12 and we need to multiply that by 3x. I like how we wrote this out here at the very beginning so people can see that. Then we're going to pull down our plus. Then we're going to take our 12 and we're going to multiply it here by 8. Okay, and that second multiplication is written right here as well. So now it's just a matter of grab your calculators, because this is some computational work, and you're going to multiply together your numbers. You're going to take 12 times 3, which gives you 36. So this is now 36x. We're going to pull down our plus sign here, and then we're going to take as our last part 12 times 8. 12 times 8 is 96. Now, these two numbers, 36 and 96, cannot be added together to give you 142. And the reason being is they are what we call, they're not like terms, which is what we're going to focus more on tomorrow than anything else. What is like terms, what is not like terms. But for right now, we're just looking at problems where all I have to do is distribute, and there's nothing to do after I've distributed. This is going to be my final answer for problem number 1. Okay? Now in problem number 2, as we've seen, it doesn't matter where your number's at that is being distributed. So like in problem number 2, we took the number that was in front in problem number 1 and we moved it behind in problem number 2. Again, we have arrows here that represent each of our multiplications that need to take place here. Okay? So, let's see. The signs are the biggest thing that concern me here. So I'm going to leave this up here, but I'm going to show what I would kind of like what number 1 would look like here. What we're doing is we're taking 5x, and this is going to be multiplied by 3. And then we're going to subtract. Well, now we're going to take 6, and this is going to be multiplied by 3. Okay, remember the order of subtraction matters, so I can't flip those around. My 5x has to be the first part, my 6 needs to be my second part. So, now when I get to here, just like we did over here, we're going to begin by multiplying the numerical parts together. So when I multiply 5 by 3, everybody, we're going to get what? 15. We're going to get 15. So I have 15x here. Okay, then I'm going to pull down my subtraction, keep it as a subtraction. We're going to multiply 6 times 3, and we're going to be left with 18. So we're going to have 15x minus 18 as our final answer. And that's as far as you can go. Okay, I can't combine 15 and 18 because, again, those are not like terms. And I also want to make sure that the order of that is not flipped around. Because 18 minus 15x is different than 15x minus 18. Okay, please, if you have questions, ask as we are talking about this. Because I'm going to be honest. Yesterday there was a lot of computational work. Like, most of the problems on the homework, it's not necessarily my favorite book assignment. Most of them did not require you to use the distributive property. You could have cheated your way through and just used the calculator. This is the big idea you need to get from last night's homework. Okay? I'm not going to ask you to do mental math and multiply 5 by 98. Because I know you're going to use your calculator to multiply 5 by 98 and you're going to get 490. Okay? What I am going to ask you to do is simplify an algebraic expression. This is the big idea you have to be able to do. Your calculator will aid you in getting the answer, but it is not going to give you the answer. Okay. Now, in problem number 3, we are multiplying a negative 6 by these two things inside the parentheses. So we have two multiplications that are happening. Again, I like the work being shown here. We're taking negative 6 and we're multiplying that by 4x. And then we're adding negative 6 times a positive 10. So here we're going to multiply the numbers together. Negative 6 times 4 is going to give us negative 24. So we have negative 24x. Then we can pull down the plus if we'd like, and we can take negative 6 times 10, and negative 6 times 10 is a negative 60. Now, I will talk about this as well. I will always write it like this when I get done. But hopefully we recall from adding and subtracting integers earlier this year that adding a negative is the same as subtracting. So we need to understand that these are equivalent algebraic expressions, and we talked about that definition yesterday. Okay? Either one of these would be counted correct. For us, where we're heading, this is how I'm going to start to write it. Now, here's what I want to point out. You multiplied by a negative number. So we talked about this yesterday in our last two examples in our notes. Anytime that you multiply by a negative, what did we say is going to happen to a number or variable? The sign is now going to flip. It's going to become the opposite. So if anything started as a positive number inside my parentheses, it needs to change to a negative when I get done. And really, that's what we've done here. Okay? Now, in problem number 4, the negative that we have is behind my parentheses. Now, this is kind of a big deal. Why do we have parentheses here? Because if not, what would people view this as? As a -2. I don't want -2. I actually want it multiplied by -2. We need to understand that there's a significant difference there. So, we're going to take -2 and multiply it by -12x. We can pull down our plus, and we're going to take 6 times -2 as the second part. Here, a negative times a negative becomes a positive. So I have a positive 24x. I can pull down my plus. A -2 times 6 is a -12. Or, I could write it as 24x minus 12. They both, again, are mathematically the same expression. Again, here's what I'm going to point out. The signs on both of these changed. My negative became a positive. My plus became a minus. Because I multiplied by a negative number. Always paying attention to your signs. Not just the computational part of it. If I don't have the correct sign, there's a huge difference between a number being 18 and a number being -18. I need to make sure that I've got the correct number for these as we move forward. Alright. Questions? Because I feel like we should have some, but I didn't see a whole lot of people jotting new stuff down. So, again, as a teacher, this is the feedback I use. When you don't have questions and I don't see people writing stuff down, what's my assumption? That you understand everything you need to. If you don't have a question or you're not writing stuff down, you're telling me that either number 1, you get it, or number 2, you don't care. And if you don't care, I can't fix that. That becomes I need to understand this idea. Because I'm going to tell you right now, ladies and gentlemen, said it yesterday, I'll say it again. If you don't get this isn't like one of those, oh, I didn't get fractions and so I'm just not going to understand fractions. As long as I can get my level 1, I'll be okay with that. If you don't get this, you're not going to get the rest of the year. This is not a concept, I'll be honest, that is ever going to go away. Ever. You have to know how to distribute correctly. Now, I'm not saying you got to be pro at it now, but I'm going to tell you that if all you can get is a level 1 on your assessment, that doesn't bode well for the rest of the year. At all. Okay? Alright, so, last chance. Questions, concerns, comments? Yes?
So, like, on the problem going, you put, like, 6 times 3.
Yep.
And, like, would it matter if you did, like, 3 times 6?
Nope, because the order of multiplication doesn't matter, so 6 times 3 and 3 times 6 are going to give us the same answer.
Wouldn't it be the same thing if we were, like, adding them? It's like the same thing. They said
What's
they're
that?
equivalent. Because when you're, like, adding and...
Right, so I'm not going to care if you have plus a negative 60 or minus 60, either one's fine. My preference for where we're going in unit number 4, which is a week and a day away, that's it. My preference is that you start to write it like this. Okay? Because here's what we're going to do in unit number 4, ladies and gentlemen. We're going to do this, and now we're going to set this equal to 48. you're going to have to solve that equation. Well, if you can't distribute correctly, you don't stand a chance of solving that equation. So this is going to equal 48. This will be the easy part. Then we'll have to teach you all the new stuff on how to solve that. Okay? All right. So let's go ahead and take a look at your homework assignment, please. All right, now, you're going to have to pay attention to this one because I just got a brand new computer this morning and they're still installing some of my programs. And one of my programs that needs to be installed is how I show my homework. So I'm going to read it today. You got to focus and pay attention as we go through this. Okay? Number 1. I'm not going to read the entire question, I'm just going to read the answer. Number 1 should be the distributive property. Number 3 should be 288. Number 5 should be 17.9. Number 7, I told you guys, this is the big thing we need you to be able to get. Number 7 should be 2x minus 12. And number 9 should be 20k plus 45. Number 11, there's 3 parts to this. I'll write it down here on the board. 11a said, explain how you'd find the entire area of the rectangle is one big rectangle. You're going to take the length and multiply it by your width, which should be this right here. Okay? 11b says, what if you did them individually? You'd find the area of one room to be 300. You'd find the area of the other room to be 15 times L. That's how you'd find the area of it the second way. And letter C says, show that these two expressions are equal. Well, what you're going to do is you're going to take 15 times 20 plus L. You're going to distribute. That becomes 15 times 20 plus 15 times L, which becomes 300 plus 15L. There is an equivalent algebraic expression. That's all you needed to do. Okay? Now, again, the next ones are number ones. So again, more than half of your homework was calculator work. That's not what I'm worried about. I'm worried about, can you do this using the distributive property? Number 13 should be 30. Number 15 should be 18.2. Number 17 should be a negative 81. Number 19 is 9. Number 21 is 763. Number 23 is a negative 1,980. Number 25 is 3.98. Number 27 is a negative 36.18. Number 29 is 3y plus 27. Number 31 is negative 7s minus 140. Number 33 is a negative 25q plus 20. And number 35 is 16n plus 24. All right, Cynthia. Number which one? 17. All right. So problem number 17 says use the distributive property to evaluate the following expression. So we have 6 plus 21, and this is being multiplied by a negative 3. It did not say use the order of operations. It said use the distributive property. So I'm not adding 6 and 21 together. I am distributing my negative 3. So I'm taking 6 times negative 3, and I'm adding 21 times negative 3, because that's what the distributive property tells me to do. Okay? So if I take 6 times negative 3, this should be a negative 18. We're going to add to that 21 times negative 3, which is a negative 63. Then if I want to add those two together, negative 18 and negative 63, they add to give me a negative 81. That's how we use the distributor property to evaluate an expression like that. Serena,
Repeat the answer again.
for which one?
3.
3 was 288. Hayden. Okay, number 5. Number 5, again, I didn't want you to just use a calculator for this one, because that defeats the purpose of what we're trying to do. 2 times 895. You might say, I'm never going to do this. Well, ladies and gentlemen, welcome to real life and money. How much are 2 items that are $8.95? You should be able to do this without grabbing your cell phone and using the calculator feature. So, first of all, $8.95. Think about it as $8.95. It's really close to what? Really close to $9. So we're going to make this 9 minus 0.05. $9 minus a nickel. Now when I go to distribute here, I'm going to have 2 times 9 minus 2 times a nickel. 5 cents. 2 times 9 is what? 18 minus, if I have 2 nickels, that makes a dime, which is 10 cents. And when I subtract those, I have $17.90. Next question that we've got. Chloe,
35.
number 35. Now, number 35 is asking you to simplify an algebraic expression. So we have negative 2n minus 3, and this is being multiplied by a negative 8. So here's what I want to point out, and then we'll confirm this when we get done. I am distributing through what type of number? A negative. So what did we say? When we multiply by a negative, what's going to happen? All of our signs are going to change. So that means that my first number should become positive, and my minus should actually become a plus. Let's see how that's going to happen. So as I go to distribute here, we're going to take negative 2n, and this is going to get multiplied by a negative 8. And then I'm going to minus 3 times a negative 8. Well, first of all, let's start here. What's negative 2 times negative 8? 16. So this is going to give me 16n. Minus, what's 3 times negative 8? Negative 24. But what happens when we subtract a negative? We're really adding a positive. So this becomes 16n plus 24. Now, did my signs actually change in my work? Yes. This positive number became this negative became a positive, and my minus became a plus. Signs are by far one of the biggest things that cause students troubles when we're using the distributor property here. Hayden.
25.
Number 25. 25 says we have 2 times 1.99. Again, think of this as $1.99. So if I'm buying 2 items that are $1.99, that's the same as buying 2 items that cost $2, and we're subtracting a penny from that $2, right? So if I were to distribute 2 times 2 minus 2 times 0.01. Well, 2 times 2 is 4. 2 pennies is 2 cents. So if I have $4 and I'm subtracting 2 cents from that, that's going to leave me with $3.98. 3.98. All right, let's keep going. What else do we have? Emma.
21.
Number 21. 7 times 109. What's a number that's easy to multiply by that's close to 109? 100. So how can I rewrite in 109? 100 plus 9. Now if we distribute here, 7 times 100 plus 7 times 9. Okay, what's 7 times 100? 700. What's 7 times 9? 63. If I add those two together, I get 763. Now, here's the crazy part. Who remembers a long time ago you guys doing multiplication longhand? Yeah? If you don't, that's fine. But if you were to show your work with this, this is nothing other than the distributive property. So I said this yesterday, like the lattice method that some of you guys may have now learned, it's just this. But again, this is more time consuming than this is. Like if you were to do this, you take 7 times 3, which is 63. So you put a 6 or 3 and add the,
6 and 0.
add this. So 0 times 7 is 0 plus 6 is 6. And 1 times 7 is 7. You'd still get 763. Okay? Do you guys remember doing problems? I'll make it somewhat small. Remember doing that? Okay, you do 1 times 4, which is 4. 1 times 1, which is 1. What did they tell you to do after that? You put a 0 behind the bottom of that. Then you take 1 times 4, which is 4, and 1 times 1, which is 1, and then you'd add down, wouldn't you? And you'd get 154. Everyone remembers kind of doing that by 2-digit. Now here's what I'm going to show you, ladies and gentlemen. 14 times 11 is the same as 14 times 10 plus 1, right? What's 14 times 10? What's 14 times 1? Do you guys see that it's the exact same thing you did right there? When you learned to do this, whatever you did, that's all they were telling you to do. People are like, I don't understand why. Like, this is all this is it's the distributive property. So whatever elementary, middle school teacher taught you that, they could have taught you the distributive property, but I'll be honest, most of us aren't mentally ready for it at that point. But that's all it is. That's all that is. That big long algorithm we did, it's just the distributive property. Okay? All right. Quentin.
23.
Number 23. Number 23 says we have negative 5. This is being multiplied by 396. Again, what's 396 really close to?
400.
That's really close to 400. So how could I rewrite this? 400 minus 4. All right, now let's distribute here. So if we distribute this, we now have negative 5 times 400 minus negative 5 times 4. Again, what's negative 5 times 4? Negative 20. So negative 5 times 400 is negative 2,000. Minus, what's negative 5 times 4? Negative 20. What happens when we subtract a negative? We're actually adding a positive. Negative 1,980. Serena, number 15. Says we're taking 7.2 plus 1.9 and we're multiplying that by 2. Sorry, 15, not 17. 7.2 plus 1.9 times 2. Use the distributive property. So we're going to take 7.2 and multiply this by 2. And we're going to add 1.9 and we're going to multiply that by 2. Okay, 7.2 times 2 is 14.4. This, again, I'm actually using the distributive property here. What's 2 times 2?
4.
4. This is 3.8 then. You guys see how I got that? I made this into 2 minus 0.1. 4 minus 0.2 is 3.8. Now when I go to add these two together, I'm going to end up with 18.2. Come on. Number 29. 3 times the quantity of y plus 9. So, simplify this expression. This is not one where your calculator is going to help you other than your computational work. We're going to multiply 3 times y. And we're going to multiply 3 times 9. Well, what is 3 times y?
3y.
It's 3y. What's 3 times 9?
27.
There you go. Since I'm multiplying by a positive number in here, none of those signs should change. So that's again something that I encourage you to continue to check as we simplify expressions using the distributive property. Delaney, number 31. All right. Number 31 says we have s plus 20, and we're multiplying this by negative 7. So if I'm multiplying by a negative, what should happen? All my signs should change. So anything that's positive, which is both of these, should become negative when I get done. Let's confirm that that's going to happen. We're going to take s times negative 7, and we're going to add 20 times negative 7. Well, s times negative 7 is negative 7s. We always put the number before the variable, because otherwise people might think it's s minus 7. We want it to be negative 7 times s. Plus 20 times negative 7 is a negative 140. Now again, this is an example of plus and negative. This would be fine on your assessment. But what I also want us to realize is that is equivalent to negative 7s minus 140. Both are telling me the same things. All right, what else do we have?
33.
Number 33. All right. With number 33, we have negative 5, and then in parentheses, 5q minus 4. Again, if I'm multiplying through by a negative, these signs should change when I'm done. So as I go to distribute here, hello. Hi. I do. Okay, thank you. Bye. Delaney. You're in trouble. Come here. All right, so we're going to take negative 5, and we're going to multiply this by 5q. Then we're going to minus a negative 5 and multiply that by 4. So what's negative 5 times 5?
No, 25. Well, no, negative.
Negative 25. So negative 25q minus, what's negative 5 times 4?
Negative 20.
Negative 20. Now again, I'm not going to let you leave it like this. If you leave it like this on your assessment, it's wrong. Because minus a negative should become a plus. Negative 25q plus 20 when I get done. I'm okay if you leave it like this on your assessment. I'm not okay if you leave it like this. Okay, and again, here's what I'll point out. Your positive became a negative. Your subtraction became a plus. Signs are constantly changing. Now, I'm glad that we got questions, and I don't want this to stop. I wish if we could continue more and just get going, we would. But I know we still have some, so I want you to mark those on your paper. And we need to begin 7th period with this same discussion, so we are solid with this. Okay?